Alright, so today we'll be talking about the uh, central limit theorem. Okay, and the central limit theorem is basically this. Okay, states that given a distribution with a mean of mu and a variance of sigma squared divided by, I believe it's nope, not divided by n. The sampling distribution of the mean approaches a normal distribution with the mean of mu at a variance of sigma squared divided by n as n, the sampling size, increases, which doesn't make any sense because in our normal mathematics, as the number underneath the actual number being it's basically saying that this number underneath, as it gets bigger, this number will actually approach this number, which doesn't make sense because that's a kind of a paradox because we're increasing the denominator. And usually when we increase the denominator, the number is supposed to go down, not up. Okay? Right. Below, in this example right here, below are shown the resulting frequency distributions, each based on 500 means. For n equals 4, 4 scores were sampled from a universal distribution 500 times, and the mean computed each time. So it turned out to be something looking like this. The same method was followed with mean scores of 7, with means of 7 scores for n equals 7 and 10 scores for n equals 10. And as you saw, as you worked it out, the distributions became more and more normal, and the spread of the distributions decreases. And it's some of the most interesting stuff that you'll ever see. And so this is an example of what the central limit theorem is. And remember, n is not the number of items in each object, but it's actually the mean for those amounts of scores. So remember, for n equals 4, 4 scores were sampled from a uniform distribution 500 times. So you did it 500 times, but you did 4 scores. You selected 4 scores at a time, okay? All right? All right, so as long as your job is up to date and you're clicking on these and working with the actual experiments, this stuff gets pretty easy. But just remember, as the size of the mean of the sample sizes increases, this stuff definitely does get closer and closer to normal distribution. So we've come full circle back to normal distributions, okay? All right, that's it for the central limit theorem. I'll talk to you later. Bye.